Bismillahirrahmanirrahim. Assalamu alaikum everyone. Good morning to all. Imagine a world where the impossible becomes possible and where the dreams materialize into reality. Today I want to invite you to embark on a journey into the enhancing realm of Gemma Extended Day organized by TensorFlow User Group Bangladesh, where the crucial topic is the magic of transformer model behind the generator. Well, today's my agenda is first of all what is Gemma, and then Gemma versus Gemini. After that, I will talk a little about generative AI, and I'm pretty sure that we all are familiar with this term generative or Gen AI. After following that, I will talk about traditional deep learning and finally transformer. So let's start. What is Gemma? Well, Gemma is a family of lightweight open AI model built in Google that is developed the same team who's built the Gemini, and the interesting thing is that it also developed by DeepMind and Google researchers. They contributed to Gemini also, and I called the DeepMind is the birth of Gemini place. We will also see later about the Gemini, so stay with us. Why it's called Gemma? Well, the Latin Gemma comes from the Latin word which means this precious stone. The- You can see a picture in the left right bottom that there are some precious stone. So what comes in your mind after that the word, like if you got it from anyone, it's valuable for you as Gemma is in our right now open source model is on the top notch, and it's available from all the worldwide, and you can use it from today. So type of Gemma. Well, if I said Gemma is divided into two parts like Gemini 2 billion and Gemma 7 billion, which means that Gemma 2 billion a neural network of 2 billion parameters, and similarly the 7 billion para. But the thing is that the researchers extended it more to part. One is category is pre-trained model, and another is uh, instruction tuned, which means that we can customize it based on our necessary. And also the one thing is that Gemma is LLM model, and it's not like powerful Gemini family like Ultra Pro or Gemini Nano. We will so later move. So here we can see a picture that compare the state uh, of the art performance at size. At first, what does mean by the state of the art performance, which represent the latest or the top perform model version. So we can see there the comparison Gemma and LLM2 who is developed by Meta, that we can see Gemma 7 billion compared to LLM2 model 7 and 13 billion. Almost not almost every part we can see that the Gemma outperformed than LLM2, and the we can see that the major part in the math where Gemma performed 46.4%, that where LLM to 7 billion perform only 14.6. That's a huge difference between Gemma and LLM model 2. As well as we can see that the code section has Gemma extremely outperformed than LLM model 2. We can in this picture we can see that the Gemma model compare with others three model, and the first two categories like question answering and reasoning both where all models are performed well, as we uh, the things come in our mind when we had the LLM like question answering. But if we go more difficult like the real world math or science problem and the coding, we can see that the Gemma perform well compared these three model. And this is the also broad picture about the comparison of this Gemma with other model. And the benchmark, we can see that mmlu, the large value. So we can see that bottom the line average, where we can say the Gemma perform 56.4%, the top of the other model. That's why, and Gemma is the top of the town. And you know that. So where does it run? Well, earlier I said that Gemma is a lightweight model of OpenAI models, and that like Gemini we cannot run in our laptop because of its complexity and the closed source code. And in the Gemma is an LLM model. That means that it can we can perform only the text to text and the related things, summarizing chatbot, etc. So this model we can run in our laptop, desktop, mobile device, and as well as public cloud. So how differ Gemma from others model? As we are talking about Gemma, we can compare it the Gemini's family. Mm, first of all, that Gemma is not the first Google OpenAI model. Earlier that they developed transformer, and uh, what I say transformer BART T5 PM2 model. And but the thing is that compared to BART and T5 model, Gemma performs well. And another the big difference is that we can see the previous picture also, Gemma perform well on the scientific stacks, where L2 model work on general purpose. And I already said that Gemma is an LLM model, means large language model, is not LIM. We cannot perform image generate through the Gemma. Uh, what is used for? Well, we can create chatbot through Gemma, summarizing text and real-time Genai application. So we want to explore some Gemini. Before I going that, I tell the one thing. This is the DeepMind situated in the London, uh, daughter of called Google. Like Google maintain the DeepMind, where the Gemini Braun as well as some researchers contribute. Okay, so we can go the deep mind site, where we can see more things about the Gemma. We can select the benchmark. The benchmark means that based on the things compared which model perform well. If we select math, we can see that this Gemma perform well than others open LLM model, and we can select anyone what we want to see from there. After that, uh, how do we access Gemma? Well, in the day 2 we will see how use Gemma using uh, try to all of these three see, and that's all about Gemma. So Gemma comes from the Gemini, so we also see the Gemini what it do. Well, first of all, welcome to Gemini era. Gemini has three sizes: uh, Ultra, Pro, and Nano. It has own uh, advantage depend on the situation and categories. So the interesting thing is that Gemini perform 90% where an expert human perform 86.4%. So Gemini is multi task model, which means that we can perform through Gemini uh, text to text, text to text summarization, image to text, text to image. All of things we can perform through Gemini, and where uh, Gemini is from the generative AI, and we know that generative AI two part. We'll also discuss about this, and so here is and the comparison between Gemini 1, the benchmark including text and coding. So we can see that uh, every sector Gemini perform out well than GPT-4. GPT is the came after the transformer release. So if we consider ChatGPT equal to GPT-3, that's the wrong thing. That GPT is the others version 1, 2, 3, currently running 4, and ChatGPT is just a tool that we use. As I earlier said that multi-model, so here we can see that the image comparison between GPT-4 versus Gemini, we can see that it perform well as well, better than others model. If you want to know more about, we can visit the technical report. You just click here, it can show a PDF as how the train model, and uh, just wait to load the page. But in the meantime, I tell you that Gemini code you cannot find because it's a closed source, and here you can see that the transformer. We will finally talk about the transformer. Based on transformer, right now everything is developed, like you say GPT or LLM model, or you can consider the Gemma model. So we can see, just consider this is a black box. We pass any input, either it can be text, audio, video, or image. After the insert the model, it output give us uh, either image or text what we want. And also there you can see the many comparison table. This is technical all about the Gemini model. Okay, so we had the some things that, like, before I come here I want to talk also about the generative AI. As everything is connected each other, uh, like we say the Gemma is came based on Gemini, and it's from generative AI. It's a chain rule where generative AI comes from. Generative comes from uh, after transformer came from DL. So I do not go deeper from this. I just talk about this. So in the deep learning, what we can see that, sorry for that. Uh, Deep learning model broadly categorized into two part. One is descriptive and another is generative. So uh, we know that ANN, CNN, and RNN all are deep learning model. They work as an descriptive, like supervised learning. We trained with the data, and whenever we give the input, they can give us the output. They cannot generate the content. So, and the before NLP revolution, we also see that another deep learning model is RNN. The RNN perform well before introduce the transformer, but it can perform only the small text. For example, if the text length has 5 to 6 word, it can perform well. So it can translate very small sentence. Then the researchers how to remove the vanishing gradient problem, then to introduce the transformer with us. So we just beg to see and uh, how looks like transformer model. After that I will come here. The transformer model is the prime paper is attention is all you need, that developed by Google Brain and Google researchers. And like this is the transformer architecture. It's look like small but it's very powerful and scalable. Okay, what's going on? So after the transform evolve with us, and at that time, few days later, the generative AI introduced. We know the generative means it can generate new context, but in the deep learning, the problem is it cannot generate new context. One second. Okay, generative model like this is an Gen I. It's divided into two part, LLM and LIM, which the large language model that deal with the text, and on the other hand, LIM deal with the other images model. So like this is and our Genai model, we just give input as a prompt. It can be image or text. Based on this, we give the output. So I do not deep dive into the more about generative AI as our the focus and we also talk about the Gemini. So in the Genai, generative AI, we see that LLM and LIM perform individually, not togetherly. This merge in the Gemini. They developed based on this strong model. And after that, the Gemma comes from for developers, and the end user can test as open source it. We cannot run this Gemini model because of as I already said that we cannot run in our local computer. They need more computational GPU and also a billion of data. So that's why they give us the light model. the Gemma. So if you like this the transaction place, this is the DL and this is the generative including the Gemma Gemini. The middle part is the transformer which help to the revolution. So transformer has three part, like three work. Before that we also go to the paper, and I already said that the transformer developed because of to reduce the vanishing problem. And this is the model architecture which is mainly two part, input and input is like encoder and output is decoder. In the input, there's nothing. There's the familiar thing like the multi-head attention, feed forward, addition and normalization. And here we also see the residual connection. Residual connection architecture, if you remind, is like ResNet. So they also subpart into how the work, like if the single input it based in the inner side query key and value. I'm not telling about the math. It's also you can guess that the complex math. So I'm not good at math, so I'm not deep dive here. So this is the landmark of the transformer paper, and we can see that how many models are currently based on the transformer. If we visit the paper, a comprehensive guide, we can see, like here we can see a smaller picture. Every task of the Genai model use transformer, from starting NLP to computer vision multimodal and audio speech to signal processing. So we want to also deep dive about the transformer as it's the core part of any Gen AI model. So first of all, I come to the paper. I share with you three things. Uh, this is the basic ANN model. What happened there? We can see this is the input, and input has many hidden layer, and then we find the output. Based on the neural network, they can develop, they change the name. Okay. So the I'm not going at too deep. Just give a overview that consider the transformer is also a black box. We just give an input, like this is in Paris sentence. It can convert to the English. It can easily do that. We already use uh, the BART. Currently, it's named Gemini, and also we have experience about GPT. So transformer has three parts. First is embedding, and the second one is attention, and the third one is self attention. So here we can see a picture that football legends. I included it for clear understanding about the attention. uh, we know the word and we also familiar with the attention. What does it mean? For example, if I tell that count the how many footballer are there, so the my goal is counting, not the detect individual person. So I just count and then tell the answer. But if give ask me specifically where is the Ronaldo's position, we can try to find him and ignore others thing. That's look like attention word. So in the embedding, it's a positional embedding. It means that like this the sentence, and it can give and uh, just for understanding is I tell that it give this the position, or you can call the index, and then attention. So what does attention means? For example, I and student, and we can also guess that in the inside what will happen, I am or I is. Like this the attention is which one is the next it find, and self attention uh, perfectly like I is or I am, which one is better, the self attention ensure this. So if I want to tell like these three things with a story, is like that positional embedding. You can consider when you read any text, the order of the word, which one after one, like I am after I, we cannot read student. It's maintain a serial, uh, and already I attention described, and the self attention again I repeated that like you are reading a book and come across word you do not understand, but you want to find where the word used before to understand. So self attention ensure that to better matching or understanding. Now we back to the I am not describe about this picture. This is a self attention picture, like which one will meet after the. This is the sentence is converted in a vector. Each one like you can consider an index, and we can see that after the word which one will come, every one can connect it with others. So here just for the simplicity they can show the simple answer, like we can see after the we this line animal is the mm, more color than others line. This is the less color, this also less, like after it we cannot put it. We see the basic grammars that to it never used consecutive. So uh, if we also others said that the paper indicate that what the it refers, the animal or it was too tired. So which things? So clearly we know that the animal, but model cannot model uh, calculate this, and then based on the probability they return the result. I revisit the paper again. Attention is all you need. Is the uh, core part of, uh, or based on this the transformer built, and it has two things: single-headed and multi-headed attention. So this, and here is the clear visualization of the transformer. We can see that we already see the picture, give the input and it can translate the word, and we know that whenever we tell the GPT-3 tools like ChatGPT that translate the word into other word or summarize the text, it can do that easily. So how they do? Uh, in our architecture we already saw that it has two part, encoder and decoder. If we broadly said each encoder, it has a number of encoders, like the we do not pass the input encoder and it do not pass the decoder and we do not give the output easily, how we see that, but inside it has many layer. And we also see that each encoder, it has two subparts, self attention and a feed forward neural network. And similarly, both encoder and decoder are almost similar. And whenever we give and the input, it divided like the vector, and each vector size 512. And the thing is that the it's work parallelly. So in the RNN, the problem is that it cannot perform well on parallel. Yeah, and that's the picture that we see previous on the notes, one note, that here the sentence is the animal didn't cross the street because it was too tired. So what does it in this sentence refer to? So it we after reading the sentence we clearly say that it refers the animal. But how machine pass through word one after one, so they calculate with based on query values, and also consider the attention and self attention. And here is the more explanation of self attention. uh, I will share that what I understand from here. Each after embedding, it has three parameters: query, keys and value. And every times embedding and queries multiplied, and with find the weight matrix. Similarly, keys and value. So we see that the deep learning is based all about the matrix multiplication. And you can see also that how it's work. There you can see that a table. So that's all about transformer. If you have interested, you can visit it. Okay, so far anyone have any question? I see that there is a member. So if you have no question, I can ask. I will tell about something, the Genai revolution. So uh, let's talk about something, the descriptive model and generative model. What happened in the descriptive model? As I told that it's super biased model, that we train the model and we find the output based on this. And the generative, it create new content. If we see, like we give the text, it can return the image, like Delhi to Mid Journey. And also right now Gemini give us this flavor. And in the day 2 I will show the demo code about how to use, and also develop some chatbot using Gemma. uh, that's all about today's presentation.